Welcome back to my YouTube channel. It's still the online science tutor. For those of us that have subscribed to this channel, I want to say a big thank you. You have been amazing. Thank you so much. And for those that are yet to subscribe that are still thinking, should I or should I not? Please do subscribe to this YouTube channel. It's going to be really something that you will be glad. Chemistry is a branch of pure science that studies matter and the changes that matter undergo. So, one would want to say, what is matter? So, matter is anything that has mass, that's weight, and occupies space. So, if matter is anything that has mass and occupies space, that simply means that everything you see in nature is matter. So, in studying matter, that chemistry is the study of matter, we cannot just study the matter as a bulk, as a whole. So most times we want to look at the smallest particle of that matter. And so this will make us to come over to the definition of atoms, molecules, and ions. So, atoms. Atoms are the smallest particle of an element or matter that can take part in a chemical reaction. So we say matter is the smallest particle of an element or matter. Atoms rather. We say atoms are the smallest particle of an element or matter that can take part in a chemical reaction. So from this we know that atoms make up everything in the universe. Atoms make up everything in the universe because matter is what makes up everything in the universe. So according to the Northwestern University, the term atom comes from the Greek word that stands for indivisible. The atom is the smallest indivisible particle of an element or matter that can take part in a chemical reaction. But over time, the atom's atomic theory has needed to be modified because of the fact that science has progressed and the presence of more powerful microscope have shown to us that the atom can be divided. So atom is subdivided. So that word indivisible no longer applies to the atom. Every atom is made up of protons, neutrons, and electrons. So it no longer suffices to say that the atom is the smallest indivisible particle of matter. No. So an atom can be divided. Okay, so we simply say the atom is the smallest particle of an element or matter that can take part in a chemical reaction that is made up of the protons, the neutrons, and the electrons. And like one is positively charged. The neutron is neutral, it doesn't have any charge, while the electrons are negatively charged. Generally in nature, every atom is electrically neutral. So that means that the atom is not carrying any charge whatsoever because the amount of proton is always equal to the amount of electrons. So the amount of protons is always equal to the amount of electrons. By way of recap, so far we have said that in dealing with separation techniques, we know we are working with matter. Every study we are undertaking in chemistry is a study of matter. It's a study of a particular aspect of that matter. So for today we are looking at separation technique, which is also an aspect of chemistry. But this will not be possible without knowing what really is this matter we're talking about and what makes up matter. So we said matter is anything that has mass and occupies space. And from that we know that everything in the universe is matter because they have mass and also they occupy space. Is the smallest particle of matter that can take part in a chemical reaction, and that the word atom was derived from a Greek word that implies indivisible, because earlier on scientists thought that the atom is the smallest particle and so it cannot be divided. But then research now shows that the atom can be divided, and so there had to be a modification to the Dalton's atomic theory. So the atom is no longer the smallest indivisible particle. No, it's just the smallest particle that can take part in a chemical reaction. Okay, so if we have established that, then we went on to say that every atom is electrically neutral because it is made up of three different components, which are the protons that are positively charged, the neutrons that are neutral without any charges, and then electrons that are negatively charged. Okay, so what does this have to do with separation techniques? What this has to do with separation techniques is that if atoms are joined together chemically, that is, if they take part in a reaction and then they are joined together chemically, we cannot separate them, because one, new substances are going to be formed, and these new substances have an entirely different chemical formula. So when we are looking at separation technique, we are looking basically at mixtures. So we are looking at mixtures and not compounds. A mixture is a combination of two or more types of matter that are physically joined or combined together, with each component retaining its own physical characteristics. If I have a mixture of sand and water, for example, the sand still retains its nature of being a solid, while the water retains its nature of being a liquid. If it is left to stand for long, there will be a separation of the two distinct layers. So we're going to be seeing the solid phase of it and then the liquid phase. So a mixture is two or more constituents of matter that are physically joined together, with each component still retaining its own characteristics. Okay, so this knowledge of the fact that in a mixture each constituent still retains its own physical characteristics is what is made use of in separation techniques. So the entire idea of separation techniques is something that we are only using a difference in substances to separate them based on what we intend to get at the end of the day. So separation techniques basically makes use of the characteristics of the particular component of that mixture. So for some, I'm making use of the difference in size of the various components that make up the mixture. For some, I'm making use of the difference in their boiling point. For some others, I'm making use of the differences in their solubility. But don't forget, you cannot separate a compound, substances that are joined together chemically. You can separate a mixture because of the individual characteristics of each of the components that make up that particular mixture. I'm going to list the various separation techniques that we have and thereafter we're going to be studying each separation technique on its own. Sieving, then magnetic separation, sublimation, decantation, filtration, centrifugation, evaporation, dryness, crystallization, fractional crystallization, precipitation, distillation, fractional distillation, the use of the separating funnel, and chromatography. Alright, so at WAEC level, you are going to be tested on when your knowledge of these separation techniques using very similar examples around you. So just stay to the end of the lesson, because I'm going to be bringing out questions where these separation techniques have been featured in past questions, so that you can see what to watch out for under separation techniques. So each of these separation methods has a particular characteristic that it focuses on to enhance separation. And also, don't forget that matter can exist in any of the three phases, which is solid, liquid, and gas. So for solids, there can be a mixture of a solid and a liquid. So whatever separation technique I'm going to use in that case, I'm going to also look for a way to take advantage of that difference in their states to work. Okay, so we already listed the types of separation techniques. So right now I'll be dealing with separation techniques that are used to separate solids. So if I want to separate solids that are of different sizes, I can make use of the difference in their size to separate them. So most times, either of these three methods can be used. So sieving, two, magnetic separation, and three, sublimation. So for sieving, I can easily use sieves, that's a mesh of a particular size to separate solids that are of different sizes. So if I have two solids, for example, one of them is 2 millimeters, I can actually, and the other is 5 millimeters, I can actually design a mesh that will allow the 2 millimeters size particle to pass through while holding up the particles that are of 5 millimeters. So in that way, I can easily use their differences in size to separate them into two different components. So for solid mixtures, I'm going to have to check for their sizes. Is it something I can use their size to make a mesh of particular size and see that one component, while the other stays as more like a residue that I can now filter out? So in that way, what I'm using is sieving. But then there are some solid substances that are magnetic, that they have the ferromagnetic component. So for all of those substances that are magnetic, I can easily use a magnet to separate them from their non-magnetic component of the mixture. So for example, if I have a mixture of iron filings and sand, for example, I can easily separate it by using the fact that iron filings are magnetic. So I can easily get a magnet and place it over the area of concern, and I'll see that the magnetic iron filings would be attracted to the magnet and be separated from the sand mixture. So for that, yes, both of them are solids and they have different sizes, but I'm making use of the fact that one is magnetic while the other is not. While for sublimation, there are some solids that when they are heated, so sublimation is the is the process whereby certain solids go directly to the gaseous state without first going to the liquid state. So if I know that a particular solid in a mixture of sublimes, if I know that there is a mixture of two solids and one of them sublimes, what I just need to do is to apply heat to them. The one that sublime will go directly to the gaseous state, while the one that doesn't sublime will still be in a liquid state. That way it separates out. So I now have two mediums, one liquid and the other gaseous. So the gaseous state, I can of course condense it and then channel it to a beaker, while the liquid becomes the other solid that was in the mixture. So these three ways that I've highlighted are three ways that solids of different sizes can actually be separated. So in this case, we are making use of their sizes, that's particulate size or size of particles for the sieving, the magnetic ability for magnetic separation, and of course the ability of one particular solid to sublime while the other becomes a liquid for the third separation method. Alright, so next we'll be looking at solids of also different sizes that are soluble. So solids in liquids, method of separating solids from liquids. Okay, so we already attended to the fact that when solids make up mixtures, I can separate them using either their particulate size, the sizes of their particles, their magnetic ability, or their ability to sublime. But what now happens when I have a mixture of a solid and a liquid? What can I do about it? Okay, so in looking at that, the first thing I'm going to look at is whether these solids are soluble. By soluble, I mean whether this solid dissolve in the liquid component. So, if the solids are soluble, if they dissolve in it, I'm going to need to use another method. But for most of these solids that do not dissolve in it, I can use one, decantation, two, filtration, and three, centrifugation. So, if the solids are immiscible with liquids, for example, sand and water, if I have a mixture of sand in water, we find out that if it is left to stand for a while, it's going to separate out into two distinct phases. I'm going to see the sand beneath and then the water, the clear water surface above it. But then the only challenge with this is that some of the water molecule is still going to be dirty. So, but I can get a clean bucket. So, let's say I have bucket A with the sand water mixture, and then I have bucket B that I want to use for vent. So I have bucket B to retain my solvent. What I'll do in that case is to decant. That's where it got the name decantation. So for decantation, I'm going to allow the solid liquid mixture to stand, and on standing it will separate into two distinct layers since it's an insoluble solid. And after separating into two layers, I'm going to now decant the solid from the liquid. So that's decantation. While for filtration, I'm making use of a filter paper to separate the solid and the liquid. In this case, the solid is going to be on the filter paper as my residue, while the liquid component will pass through as my solvent. So it's separated into two distinct layers, the solid substance being the residue on the filter paper, and then the liquid decanting down. And finally for centrifugation, it's with the use of the centrifuge machine and spin, which is majorly used in hospitals to separate out the various components in the blood for tests. So all of that is captured there. But then when I'm separating solids that are soluble, these methods will no longer be effective. So these methods are only effective because the solid substances involved are insoluble. They are insoluble in liquids. So for solid substances that are soluble in liquid, for example, a mixture of salt and water, I cannot decant the salt because it basically dissolves in the mixture in the liquid, and so the water becomes salty. So even if I'm decanting it, what I'm decanting is salty water, I can't get my salt back that way. So for solids that are soluble in the solvent, in the water, for example, I'm going to have to use another separation technique. So I'm separating soluble solids from a liquid. I'm going to either use evaporation to dryness, crystallization, fractional crystallization, precipitation. For solids that are soluble in the mixtures, I will either use evaporation, that's heating up the solid substance to dryness. But this is basic. Evaporation is used for solid substances that do not decompose on heating, so they are not destroyed by heat. So in that case, I can heat to dryness and then allow my water to evaporate, and then I'll get my solids back as the solutes. But if a substance will decompose on heating, if it will be destroyed by the heat, I cannot completely evaporate it because it's going to be destroyed in the process. So that's the case where crystallization now comes in, making it to become concentrated. Sometimes you seed it. By seeding, it means you are adding some solid substances of that particular solute already in the mixture so that it becomes concentrated, and then it packs together to form solid crystals. Most times water will be left behind, and that water is called the water of crystallization. Okay, so for solids that are soluble in liquids, my choices are going to range between evaporation to dryness for substances that are not destroyed on heating, crystallization, fractional crystallization, or precipitation, to just precipitate it out of the solution. Alright, so now we'll just talk about separation of liquids. So sometimes I can use distillation, fractional distillation, use of the separating funnel, and then chromatography. So I can distill one part of it out. For this fractional distillation, there's many fractions, and distillation basically makes use of a difference in boiling point and volatility. So there are some substances that the mixtures in this case are made up of different liquids that have different boiling points. So the fractionating tower, for example, is designed in this way, such that when it gets to that particular liquid's boiling point, it boils out of the mixture, and as it boils out, it becomes a gas. So it is channeled and condensed from that point. So by that process, I'm able to separate the liquid mixtures that are of different boiling points. So distillation makes use of the boiling points. Fractional distillation as well makes use of differences in the boiling point of various substances. And then the use of the separating funnel, and finally chromatography. Alright, I gave a promise that I was going to give you some questions to show you how this separation technique is reflected in your YA questions. So these are just some questions I lifted from the past questions of various years to just illustrate to you how they test your knowledge of separation technique. So this question 13 is an objective question from 1989. It said a sample of orange juice is suspected to have been contaminated with a yellow dye. Which of the methods can be used to detect the dye? A says decantation. Can I decant a dye? Chromatography, distillation, filtration, and evaporation. I'm going to enjoin that. Take a look at these questions also, and you can drop your answers to the questions in the comment section below. And then 1991 question 13, objective, said the separation of a mixture of calcium triazocarbonate 4 and sodium triazocarbonate 4 is most readily carried out using the differences in their dash. A, it uses the differences in their physical state. B, the differences in their melting point. C, the differences in their area value. D, the differences in their solubility. And E, the differences in their mass. Then question 3 says, this is 1993 objective question number 3. Which of the following is routinely applied in the petroleum industry? So which method of separation is majorly used in the petroleum industry? A says filtration, B says chromatography, C evaporation, D fractional crystallization, and E fractional distillation. Then 1993 also, theory question 1. Classify the following into a physical or chemical change. A, the fractional distillation of liquefied air. B, the cracking of petroleum fractions. C, the conversion of rhombic sulfur to monoclinic sulfur. And D, chromatographic separation of chlorophyll. I'm just going to make a statement here. Anytime you see this kind of questions of either a physical or chemical change, anyone that has to do with a separation technique, you know, is automatically a physical change, because separation techniques can only work for substances that are joined together physically, so they are physical changes. Okay, then 1994 question 11 objective said the components of the universal indicator solution can best be separated by dash method. A, they can be separated by chromatography. B, filtration, evaporation, crystallization, and fractional crystallization. All of these questions are questions that your knowledge of separation technique is actually going to be needed. And finally, also on WAEC and JAM notes, there are also sometimes when they will give the diagrammatic representation of the separation technique and tell you which separation technique is illustrated in the diagram below. So these are ways that questions are set for your separation technique chemistry. I hope you've been able to get value today. If you did, please give this video a thumbs up, and don't forget to subscribe to this channel and recommend to your friends. It's still the online science tutor. Till our next class, I want to say please keep preparing, and don't forget, you can be the very best of yourself. So have a wonderful day.